let me talk about what a series is. A series is a sequence of numbers that is added. That's all it is. Sorry. An arithmetic sequence would be 2, 5, 8, 11, 14, 15. An arithmetic series, which is what we're going to talk about today, is 2 plus 5 plus 8 plus 11 plus 14. Okay, so that's the only difference between the two things that we're doing. Okay. So the sum of an arithmetic sequence, the equation is okay, we're going to use Mr. Gauss's formula right now. So we're going to say Sn equals n times a plus Tn over 2. So what he did there is A is, I should call it T1 plus Tn. No, sorry. What I did there was T1 means what? Somebody tell me, what does T1 mean? Yeah, Chris, go ahead. T1 is my first term. Somebody else tell me what Tn equals, please. Really good? Last. Tn equals last term. Very good. No. I'm going to use n as a subscript because it has to match that number, right? All the n's are going to match be the same. What's n going to be in this case? Yeah,
That'd be like your difference.
No, difference would be d still, right? Which is still going to be d, and we'll get that in a sec. Matt, go ahead, what's that? Yeah, so I'm going to call it number of terms, right? If that's okay, so number of terms. And Sn is going to be the sum of the first n terms. All right, the problem is with this sequence is what? Well, I need the last term, which I don't like. Okay, so I'm going to make a new version of this equation. That equation will work, and you can use it to use the last term. But here's another fine equation. I'm going to set what's another way what's something I can replace T1 with? What's another thing I can replace T1 with? Yeah, okay? 1. No, let's try again. Let's go the other way. What can I replace Tn with? What's Tn the same as? Okay, what's the general term of an arithmetic sequence? What's the general term going to be? Matt, go. Oh goodness, guys, we just did a warm-up on it. 2 warm-ups. What's the general term of an arithmetic sequence? Tn equals? A plus n minus 1d. Now I'm going to call T1 equal to A. Why can I get away with calling T1 equal to A? Just started off, okay? So I'm just going to rewrite the equation then as Sn equals n times A plus n minus 1d over 2. I'm actually going to neaten that up, I think, and call it that's another equation for it. That one works as well. Okay. Just like before, n is equal to the number of terms. A is going to be your first term. D is going to be your common difference. Sn is going to be the sum of your first and terms. Now the second equation is useful if we don't know the last term, right? If you only know the first three terms in a sequence, and I say the pattern's going to go 10, 15, 20, find the value of the first 100 terms, that would be that. Go ahead.
Because you're multiplying by 2 on the top and you're dividing it constantly.
No, because it's inside the brackets, right? Like it's, you know what I'm saying? Like it's not, if, right, if there'd be a two-factor, you would cancel. Okay, go ahead. Question or no?
No.
That's what I thought you were going to ask. Okay. So those are the two possible equations, up to 4 equations in this chapter. This chapter, crazy, yes.
If you only had 3, you still plug it in, you could just pretend the 30 was the last term.
Well, no, because you'd have to keep on adding. You only works with adding the first and the last, right?
Yeah.
Like you have to have comparable numbers, right? So if you're adding 5, 10, 15, and I want to find the sum of the first 30, you either have to find the value of the 30th term, so you could add it to the first, right? Or use the second equation, right? Like you need things that balance out, right? Like for that, because I think the way it goes, the first and the last, you add all of it. So you need something comparable to it to get it to add up. I'm going to pause the video. You guys take a breath, and I'm going to get a drink of water, actually, is what I'm going to do. Then we'll come back for round 2 here.